we do have a tutor. If you're feeling lost, strongly recommend the tutor. Strongly, strongly. Great guy. Usually people walk out of there understanding things a lot better than when they walked in there. So strongly recommend that. You know, because although I think I'm a pretty good teacher, doesn't mean I'm perfect, and things are harder for some people than others. No shame, right? I can't learn music the way I wish I could. Some of y'all are great at it. I can't learn art the way I wish I could. Some of y'all are great at that, right? You know, so no shame. It's just that some people have to bang their heads on it a little bit longer than others. That's okay. And of course, you can't see what I'm typing. All right. I need to scribble and post a note on the court board about which input is correct because I don't remember. And also I'm beginning to suspect that the cable is not correct. Really, guys, if you ever become an instructor and you make changes to the equipment, I beg you to go ahead and change it back to the way you left it. All right. So go to D2L, check the notes page. You'll see the email address for the tutor. You see his name. You see the hours he's there. He's got evening hours on Thursday, daytime hours Monday through Wednesday. One of those will be more convenient to you than the others. Got his room number. Email him if you want. Set him an appointment. Or just drop by if you're in the building. Also, there is that online tutoring site or tutorial. You go to Solo Learn and sign in with your Rose email address. Choose Python 3 tutorial and just start stepping through it. And you really will learn a lot from it. I used to use cengage.com, but now they charge. Yeah, I guess you could sign up and pay if you wanted to. So, about flowcharting. Quick rehash. If you slap a diamond down, it's got to have two lines leading away from it. If you don't have two lines from it, or you don't see a reason for having two lines from it, you probably chose the wrong statement. The only things that go in diamonds are ifs and whiles. Remember that if you have a function and you have a pin that you can't see. Anyways, you have a function, you have an oval, and it's a function with a DEF. You don't call that function within itself unless you're doing a very advanced form of programming called recursion. We're not using advanced form of programming called recursion, so the function should not call itself. Instead, your main one, the one that begins with start, can have a call to that function. Function calls, module calls, they call them predefined process. At least it's got the def in it, right? Predefined process, def, are drawn inside a rectangle with bars. And then you put the name of the function and any data you got to pass to it, like if you had to pass a 10 to it, right? Then you're good to go. Had some people stumbling over that. Hope that makes sense. One more thing. Half of y'all are doing screenshots. Half of y'all aren't. That's not fair to the people who are taking time to the screenshots. I'm going to make it mandatory from all assignments from this point. You're not going to get full credit if you don't submit a screenshot. Why am I a jerk about that? Because if you can't get a screenshot, then I know right away you didn't get the assignment to work, right? Or you got it to work, but then you accidentally made a change and you uploaded it, right? And so I want to see that you got it to work. So put a screenshot in. Now, if you absolutely can't get it to work, go ahead and take a screenshot of the error. Write that useful information to me. If you don't include a screenshot, I have to load up the program, not a big deal, right? Then I have to run it. I have to make any changes necessary to get it to run on my end because I don't get to run it inside of idle. I could, but it involves a lot more copying and pasting. It's a lot easier for me to look at the screenshot, look at your code, and go, yeah, that's awesome. It changes, you know, a 10-minute grading process to a 2-1 or 1 minute. So please help me out there.
Going to make a notice to that effect. Even if the homework, just a sec, even if the homework doesn't specifically ask for a screenshot, and most of them don't. Don't do a screenshot for the daily assignments, right? I don't even make those work. I mean, right? You like to get them to work, but it's not mandatory. Need to take a screenshot? You probably know how to do it. You can Google how to do it. Windows 10 gives you a really easy facility, supposedly. Otherwise, you just hit the print screen button if you're not on a Mac. Different process on a Mac. Mac users know how to take screenshots. So you can take a screenshot that way. Hit the print screen, go into either Paint or Word and paste, and you're done. It only takes, you know, an extra 45 seconds to a minute for y'all to do that. You won't get full credit without them. You don't got to go back unless I specifically tell you in your feedback. All right. That makes sense? And yes, sir.
So the flow charts, you want us to screenshot those?
Nah. You're giving me a PDF, right? That's as good as a screenshot. On the other hand, if you can't figure out how to make a PDF, you can take a screenshot of it that way. I have some people turning it because they draw things in other than Lucidchart or whatever. Screenshots are great. If you can possibly get the code and the screenshot on the same picture, that's totally cool. If you can't, just give me one of the upload. Is that good for everybody? I won't ask if you're digging it because you probably don't, but as long as you understand it, it's good. Tell me we at the end of chapter 2. Oh man, we're not at the end of chapter 2. However, the rest of this is going to go really fast because we have already covered a lot of this. That's my style. Throw it at you before you see it. All right, so declaring variables and constants within modules. We know how to do that already. You just say A equals 10, you know. Speed of light equals 3e to the 6 or whatever it is. That kind of stuff. If it's a constant, you put its name in all caps. You know what a constant is. It's a number that's not supposed to change in the middle of the program. If you define a variable inside a module, it's only usable within that module. I don't have an idle locked here. I do. We're on J. Looks like we're on J to me. All right. And then March 4 or something like that. 5. All right. Okay. So comment. Variables and constants. I'm going to even leave that off because a constant is just a variable. Declared in a module are only available in that module. In general, you should pretend that anytime you declare a variable inside an indented block, it's only available inside that same indentation. Python's a little bit more generous than that, so I'm not going to state that as a rule. So for example, you define something called A, define A, parentheses in parentheses, colon, and you set a variable, you know, K is equal to 10, return. You don't have to have a return statement if it's not actually returning something, but I think it's prettier. You do have to have a return statement if the function, if the module actually is returning a value that the calling code has to use. We had some homework like that, I believe. Now I'm going to define another one, B. Define B, parentheses in parentheses, colon. And I'm going to print out pay and return. I know I'm typing fast, so I'm going to give you a chance to catch up. And then inside my main, I'm going to call A, and I'm going to call B. Looks great. Now this is actually kind of one of my complaints about the way that this feature works, this limit works. But we don't have a choice. Just about every programming language has this. Because I would love to have a function called, input data, and you fill out all the data, and then be able to use all that data, right? And you can actually get that to work, but it's not as easy, not nearly as easy as what this looks. I'm going to run it, and I'm going to get an error. Boom. Pay is not defined. Why is it not defined? Because this is local to A. It's inside A. I have a dishwasher. If you're living in another home, you're not supposed to be able to use it. Yeah, if you break into my house, sneak it during the night, I might notice. But whatever. This is defined here. You can't use it. This is defined in a different module, different function. That's all. There's like 3 terms for this, and the book mentions all 3. And I'm sorry that there's 3 different terms for the same concept, but that's the way computer scientists are. Can't agree on everything. This is called the scope. Like if you have a rifle scope, the only place you can use that is inside that module. If you come out over here, it's called out of scope, right? Your target is off the scope, you can't see it in your gun sight and your target. That's one term, scope. Another is lifetime. The lifetime of this variable is from when it's defined until it returns. If I did not have these return statements, the code would work just as well. It just returns as soon as it hits the first unindented statement after it, right? So if I had that gone, you don't have to delete it. I'll probably Control-Z it. It would run that, and then it would return as soon as it hits the first unindented statement. Go, wee, and then do the next thing down here. That's not going to help this. It's not going to help this problem. Still won't be able to do that. It's just that there's, an invisible return statement as soon as we hit that def, the first unindented statement. So, how do you fix that? Well, what you could do to fix that is you could return pay here. And you could I'm probably going to undo these changes. Just kind of memorize it at this point. And you could define pay as a parameter. And then you could get pay out here, my pay is equal to here, and you could pass it in here. Now, I don't know whether to leave that or not. Maybe I'll leave it. Maybe I'll leave it. I'm sorry to revise this. But what's happening now? We declare a variable, but then we return it. And when it returns, it gets stored in that variable. Then, when we call B, we can pass that in as an argument. We have a parameter variable here to pick it up. And so now it is defined here, right? That variable is defined here. It's defined in the module. Looks a little bit different because it's inside the parentheses, but it's the same thing. It's a variable. We are not passing in the variable itself. We're passing in a copy. Just like I have something awesome. I have the Constitution, of the United States, and I want to give it to you to do something with it. I'm going to make a photocopy of it so that you don't rip it up. Yeah. So this pay is a copy of this data. That's kind of important. You could pretend that it's the same variable, but that's really a bad idea. We pass it in, it can use it, and it comes back. This is no longer just a local variable that we were trying to suck up from here, right? Instead, it's something that's coming in. The weird reason we had to do that is variables declared in a module are only available in that module unless you return them. I should add that caveat there. I pick on you and Michael a lot because y'all are the closest to me. I should go, you. You know what? I should make sure this works. All right, yeah, it works. So why does this work? Because we return it and we pass it into the next one. I'm going to even put that as a comment. Why does this work? Because we return pay from module A and pass it in to module B. Would not work if we were not passing it in. If I deleted that, don't do this because it's going to break it. If I deleted that, take a look, guys who are busy trying to catch up. If I deleted that and deleted, whoops, pay is no longer defined. It's still local to here, and it's local to here, but that doesn't mean we can't use it here. All right, better undo that change. Better pause it. If you were typing along and you missed something, it was probably me changing that. I inserted that there. So the big changes were there, into these two lines. Pause if you need to. So visible, in scope, and local, those are all kind of synonyms. This variable here was not visible inside here. But later on we passed it in and it became visible. I handed my photocopy of the Constitution and it worked. Portable are self-contained units that are easily transported. I don't even know if I want to say much more about that. I'll give you an example. In our turtle code, and don't necessarily type this, guys. I'm not going to actually go full blown. Right, I did this. T is equal to turtle.turtle. Right, I created a, please don't type all this in. And then I made something like called draw triangle, right? And it used that turtle, t.left, whatever, 120 degrees, and then it drew something forward, whatever. You remember that, right? This worked because this variable was defined before here. This variable is global to the entire module, especially if I stuck it up at the top. If I did import turtle up at the top, and then I could use it inside any function. That's called a global variable. Its scope is the entire block of code, but it's considered really poor form to do that until we learn about classes and objects. However, it makes it so much easier on the turtle programs that I go ahead and do that. I kind of cheat, right? Because otherwise I'd have to pass the turtle into every single module, and it makes the code look more cluttered. So I've been getting away with using things that aren't defined inside that particular module. I didn't have to make a new turtle, I didn't have to pass it in, but it's because I defined it beforehand, which is called a global variable. I think I'll add that as a comment. Global variables are defined outside of any module above them, and then they can be used inside the module. But this is poor taste. I don't think I'm going to count off on y'all if you use global variables at this point. Not a hard and fast rule. After all, I'm using them on the turtle, so why would I be able to, no justification for being harsh on you. Just try to avoid them if you can. Constants, on the other hand, are perfect as global variables. So I'm going to change this, but this is poor taste unless the global variable is a constant. There's no reason to redefine the speed of light inside of every module. Just define it once. Up at the top of the code, it becomes a global variable that can be used inside any of them. Kind of like having a communal garden, right? You're living in a commune, and all four homes are all using the same communal garden because it's outside of the homes. Right? It's not local inside of the home. I never know if my examples make any sense. Gonna hide that for a minute. Hopefully give you a chance to type it in later if you didn't, then you wanna. Oh, let's go back. Portable are self-contained units that are easily transported. If I took that triangle class that I wrote, now I kind of wish I'd left it around. Still don't do it, right? And it used, Fred might, don't type this. It used my Fred, and whatever. It did stuff like it. If I took this code out, if I cut this code out and I pasted it in another file, it would no longer work because Fred would not be defined in that file. Variables cannot magically move from one file to the other. Now, if you put them as arguments and parameters and stuff like that, they would. But it's not portable because it's relying on global variables. A self-contained module is one that doesn't rely on any global variables. All right, go bye-bye. Self-contained module equals one that does not rely on global variables. Do we have to write self-contained modules? No, because we're not breaking our code up into multiple files yet. We're not going to hardly do any of that anyways. We may do it as a demonstration of something, but I'm not going to give you all homework where you have to break your thing up into 2 files or more. So program variables and constants are declared at the so-called program level, which means before any of the functions, outside of any of the functions. And they're visible to and usable by all modules. But many programmers avoid global variables because they can cause errors. All right, so the most common configuration for a program, or at least as this claims it. Typically, your program has declarations. Now, we don't tend to use declarations because we don't have to declare our variables before we use them. I don't have to say pay rate equals 0 before I do pay rate equals input, right? Because pay rate can be defined by the input statement. We don't have to use declarations except for globals and constants. So that's a good idea. Stick those up at the top. And then housekeeping tasks. Those are the steps you must perform at the beginning of the program. Like you want to pull out somebody's address, email address and name, something like that. You may have to go and open that file and read in the email address and the name. It would be a housekeeping task. Sets it up. Clean the house before somebody uses it. Instead, we do input statements, right? Enter pay rate, enter hours worked. They would call that housekeeping tasks. I don't know if I would call that. And I apologize. I should have brought up the code. I'm sorry, that was dumb. So, housekeeping. Stuff you got to do before the meat of the program. Detail tasks. That's the core work of the program. Quite often involving looping. You're writing a game, it's going to keep looping. Looping is like the whole key to programming. If you understand loops and you understand functions, then you are a programmer. That's where we're going. And so it's got to do some loops. Now, our programs have been so simple that they haven't looped hardly at all, right? We get input, we do a calculation, and it exits. But if we were cooler, we would have gotten the input, we would have done the calculation, we would have asked the user if they want to do it again, right? Because in the real world, you don't want to just click it, have it calculate your interest, and then quit. Instead, you want it to ask you over and over and over, usually. And then end of job tasks, stuff you have to do at the end of the program, right? We print the results or whatever. If we open the file, we close the file. Just remember this so that you can answer the question okay on the quiz, right? On the test. Housekeeping tasks, detail loop, and end of job tasks. I break them up differently. I say in declarations, input, processing, output. And each individual part can have its own input and output. Here's their flow chart. Whoopsie. Can I zoom in like I wanted to? Declarations, housekeeping, do all that stuff. Normally the house, okay, yeah, anyways. They put it in a line with bars, implying that there's a function somewhere called housekeeping, a module called housekeeping. If it was not in a module, you wouldn't do that. Now, you're not going to just create a flowchart that says declarations and housekeeping. Instead, there's going to actually be the stuff in there. Interest rate equals 10%, pay rate is equal to 20, you know, insurance deduction is whatever. Then, not EOF, I would put the word if in there, but I've already explained that I like seeing the word if in there because it makes it easier to write, because there could also be the word for or while, and they don't distinguish between the two and the three in their flowcharts, and I do. Pick which way you like to do it. And then apparently there's another module called detail loop. We just know that. If we go over here, we see that housekeeping was called with parentheses over here, right? So that means it's a function, it's a predetermined function. Detail loop is another predetermined function, and end of job is another predetermined function. Even though we don't see them defined over here, we know they are, and so we're going to call them like that. Now I don't put all function calls in square blocks. Why? Because if we're converting something to a float, we didn't write the float function. I'm not going to put it inside something with bars. If we call, something to the power of, use math.pow, well, usually we just use star star, but roll with it. Or you call a sine function or a tangent function. We didn't write those, so I'm not going to put those in bars. But the modules that we define, if we actually have a DEF and whatever, whenever you call them, you put them in a block with bars. And then once it's done with that, once this condition is no longer true, we're at the end of the file. So no longer not end of file. Kind of a little bit of weird logic. Nots kind of confuse the brain. I would word that slightly different, but anyways. And then we call the end of job function and we're done. Now they're going to give an example of that. A payroll report. It prints the headers. It prints payroll report, that's the top header. It prints these headers and then it starts looping in order to crank this stuff out, right? So the housekeeping is printing that line out and that line out, and then there's a detail loop. So your housekeeping, if you're going to go to Walmart, you better have the map, so you get the map. You better start your car, that's another housekeeping, but now you're driving, so you have to follow all the signs and stop at every stoplight and start. That's your detail loop, and when you finally get there, you buy your stuff, right? That's the end. Same deal here. That's our detail loop, and then this is the, what did they call it? End of job. And here's a code that demonstrates that. I'm not going to work you through the code. Just want you to have that concept. So a hierarchy chart shows the overall picture of how modules are related to one another. Tells you which modules exist within a program and which modules call others. I don't know about that so much. Specific modules may be called from several locations. I'm going to go back and modify my code a little bit so that we can draw a hierarchy chart for it. I'm going to just copy all this business. I'm going to paste it down here. You saw what I did, and I'm going to make some changes to it. I'm going to call this one C, that one called D, and I'm going to change that A to a C, and that one called D. Same code, does the same exact thing, but I'm going to add something to it. Make sure it works first. Don't want any syntax errors at this point because we'll get behind if we have them later. I just want to make sure it doesn't blow up the red text. Okay. I'm going to define another module called E. Define E. I'm not going to make it even do anything. So define E, parentheses, in parentheses, colon. It doesn't take any parameters, right? It doesn't have any parameter variables there. And it's just going to print parentheses, quote, E. Right? But then it's going to call C. So after print parentheses quote E, let me push this up to the top of the screen so y'all can see it. Print E, and then call C. C parentheses in parentheses, and then call D. Well, isn't that loud? Call D, but it takes a parameter, so we have to pass something in. So just for dummies purpose, I'm going to pass in something like that. This is not doing anything useful, right? I'm just demonstrating, right? It's like I'm drawing a map, but I'm just showing you how to draw pictures of houses and stores and streets. It's not a real map. I'm not illustrating something real. We're doing this so that we can do a hierarchy chart for it. It would be a lot faster if I drew the hierarchy chart on the board. The people at home would not get to see that. I'm going to draw it on the board. I apologize, the folks at home. You can see an example of the hierarchy chart in the PowerPoint. Maybe I'm not. Can you all in the back see this ding-dang light marker? Thumbs down if you can't. Yeah, okay, I have to draw it out. I don't see another. We'll press it. Is that any better? Thumbs down if you can't see black lines. That's okay? All right. although it doesn't say main down here, I think I'm going to call it main. Let me double check what the slide calls it so that I can get it absolutely right. Yeah, they call it main. Main and start are interchangeable terms. Main is just where it starts running. So we have a block called main. They called it main program, whatever. What does main do? It calls C and it calls D. I made a mistake. I want it to also call E. So come down here and put E parentheses in parentheses down here at the bottom if you're coding it. That's the last thing I added. And I added all this, right? Okay. So what does C do? Excuse me, what does main do? It calls C. This just looks like an employee chart, right? You have the CEO, and then you have the chief financial officer working for him or her, and then you have a whole bunch of peons working for the CFO, right? Like that. Same thing. We called C, we called D, and then we call E. Now C doesn't call anything. C's done. D doesn't call anything. D's done. E calls C and D again. This is not a flow chart. We don't draw lines with arrows. It's a hierarchy chart. Right? Notice that this module appears in more than one place. This module appears in more than one place. Why? Because it's called in more than one place. So that's a hierarchy chart. I don't remember how to spell it. I'm not going to write its name down there. It's just like a hierarchy chart of a company. I don't know what all those look like, organizational charts. I don't care much about hierarchy charts. I'm never going to ask you to draw one. Just remember the term hierarchy chart for the MindTap test, and you'll be good to go. And if you become a professional programmer and you're supposed to draw one, quickly Google one so you can impress your boss. Does that make sense, guys? It always terrifies me when some of y'all avoid my gaze when I ask if it makes sense. I told y'all that I was being lax on late assignments, but please catch up if you aren't caught up, right? Stuff that's well due, you should have been well turned in. Go ahead and turn it in because I've been late in grading it. Ask Jairus for help. Ask me for help. Try Jairus though. Establish a working relationship there. Dude ought to turn into an instructor. He's that good. So main loop, main program calls housekeeping, it calls detail loop, and it calls end of job. More detailed one. Main program calls housekeeping, which calls get order. Detail loop calls process order, which calls a whole bunch of modules, one of which calls another one. And then detail loop also calls get order. And then lastly, end of job calls display summary. Program comments. We've been using comments all along. You see what I mean by the last part of the chapter going quickly because we've already covered this stuff? What do you use comments for? To describe what the program is doing. Ask user for input. That's kind of vague. Ask user for values to calculate interest. That's a lot better. And then you have those statements which ask the user for the values to calculate interest. And then another block, calculate interest. See, it might take more than one statement. Usually you don't need to put a comment if it's only one statement, unless it's some kind of formula, right? You know, somebody reading it might want to know that that's the formula for calculating interest. They may not have it memorized. I sure didn't before I started teaching it, right? You know, and the calculation for calculating the area of a circle is burned in my brain, but you may not recognize it, so you would put, you know, hashtag calculate the area of the circle, right? Put a comment block up at the top of your code. Some instructors would count off, not give you full credit if you left the comment block off. I haven't been doing that, but please go ahead and do it. Be awesome. Identifiers should be chosen carefully. Avoid single letter variable names. I give you single letter variable names in here because they're easier to type. Don't do as I do, do as I say. right? Typing I is easier for me than typing interest rate. If I type in interest rate, then a third of y'all are going to mess up, you know, the spelling, not because you're dumb, but because it's hard to type, you know, exactly what you're seeing up here. Strive, whoopsie, give good variable names. Strive to design clear statements. Your code should not be overly confusing. And if something looks overly confusing, it might be time to break it up into multiple statements. I'm going to kind of give you an example of this, and I'm not sure that this is going to make a lot of sense. Let me see if they gave an example of it. All right, here's a long formula for calculating somebody's commission. It's not that hard to read, but if you're doing some kind of physics problem or something like that, it could be a lot longer. Or if you've used single letter variable names, then you know, all bets are off. It's really hard to read. You can use what are known as temporary variables. Temporary variables are some that are used just in order to set up the next line. This equation here can be broken down like this. How to calculate sales commission based on the square feet and the price per foot and the premium and the commission rate. You know, we've got 5 different variables going on, but we can break it down so that each one of these only requires 2 operands. What's the base property price? It's the square feet times the price per foot. Makes sense. We could even print it out. What's the total sales price? That's the base property price, I almost said rice, plus the premium, right? You're going to buy a lot, you know, piece of land, you have to pay that over everything else. Something like that. And then the sales commission is equal to the total sales price times the commission rate. Now, why is this better? Because hopefully it's easier to read. You could print these variables out. You could print all the steps out. Like when we're calculating somebody's pay, if we just print the total pay, that might be a head scratcher. But if we print out the hours worked and the standard pay and the bonus, right, and we print all those things out, then that makes a lot more sense. We were using temporary variables to calculate the base pay, the total pay. When we stored something in a bonus, that was a temporary variable. We didn't have to keep that around. You can, if you want to, you can write an expression that will calculate total pay based on base pay and then hours per week and then the overtime rate and the rate, that you get paid weekly. You can write all that in one long line. I never do it because it's cooler, not cooler, it's easier to read if it's broken into steps. So if the statement starts looking too complicated, see if you can break it down into temporary variables. It's kind of a logical thinking kind of thing. Now, honestly, I usually make these things kind of easy for y'all because I give you a formula and you can usually just plug things into that formula. I could tell you to look up the formula and to break it up into temporary variables. Could make it more challenging, but I don't always do that. I haven't been doing that in the past. Another good idea, write clear prompts. What does that mean? Tell the user what they're supposed to type in. If they run it and it just sits there with a cursor and a blank screen, they have no idea what to type in. So instead, you display a message, enter pay rate, right? Then they know what to do. You can be even more clear. Enter pay rate, parentheses, 12.35, right? Example 12.35, letting them know that they better not type a $sign in there, right? That's a clear prompt. Echoing the input. That's when you display what they typed in so that they can double check it, right? You're on Amazon. You pick your shipping address, you pick your payment method, you pick your shipping, method, and then before you click that purchase button, there's a screen that displays all of that. That's called echoing your input. Why? So I can eyeball it and go, oh, dadgummit, I chose the wrong address. I didn't really want to send this to myself. I wanted to send it to grandma. So echoing your input is displaying, again, what they typed in. Now you may think, well, they know what they typed in, but they may have made a mistake. So on our payroll programs, we should have been displaying all of that. We should have been displaying stuff like this. The output should have looked something like this. Even if it didn't display their name. Probably should have displayed their name. But hours worked, colon, 50. Pay rate, colon, $10 an hour. Even cooler if it had a dollar sign in front of it. Right? Base pay. Now I had to, I got into a 10-minute discussion of how you calculate time and a half. Trust me, there is more than one way. Trust me, my way works. Trust me, it may not be the clearest way. So, we could have that discussion here as well. But there's always somebody who looks at it and says, well, you know, that bonus is way less than it should be. And it's just because I calculated it differently. We could go over that, but okay. And so the base pay is 50 hours times $10 an hour. And then the overtime bonus is an extra $50, time and a half, right? 10 hours over 100 plus half of that, or times that, is equal to that. What they wanted to see, what the folks who are, I won't say arguing, that's not the right term, right? You don't argue with an instructor. Well, you could, right? But we were discussing it because we had different ways of doing it, is to show the number of overtime hours, right? And then do that. But anyways, in which case the overtime bonus would look different. And then the total, right, is $550. The dollar signs there. That would have been best output. We echoed their input. That's these two things are the things they typed in, and then the rest of it. And why would we echo the input? Because if this showed $250, they get really PO'd, and they'd like to look right. They wonder what went wrong. And then if they eyeballed the pieces of data up there and they saw that they'd, you know, typed in the wrong pay rate or the wrong hours, you know, that whatever, you know, their finger slipped, fat fingered it or whatever. Echoing your input is a good idea. I haven't been making y'all do that. It's conceivable that in an assignment I could specify that I want the input echoed. And that would mean that in the final results you should print it out again. When you look at your paycheck, your pay stub, you like to see all that information. You don't just want to see that. I guess if you're, you know, paying a gardener to do all this, then you just write a check to them, right? And then continue to maintain good programming habits as you develop your programming skills, right? Don't think that you're going to outgrow comments. You should get better at writing comments as you grow. All right, we know how to do program comments. Not part of the programming logic, right? The code doesn't care if I put comments in here or not. Even if they are statements, don't type this. D is equal to blah, 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 right? C is equal to blah, blah. If those were uncommented, it would break the code completely. The code would no longer work. Those would be syntax errors. The code ignores them. The program ignores them because they're comments, right? Just like if you write comments out to the side of a page on your textbook, it doesn't change the text, just a note for you. The syntax differs from language to language. This is a comment in some languages. That's a comment in another language. I don't remember the comment for JavaScript, but it looks something like this. Something like that, right? Different comments. That's okay. Once you learn that language, you learn its comment. It's probably the second thing they teach you in the book that you learn for that language. Flowcharts. And this is mentioning use an annotation symbol to hold information that expands upon what is stored within another flowchart symbol. I think they give an example of that, right? This is an annotation. Here's the chart, and by the way, I mentioned this to somebody. Don't put multiple statements in a single square block unless they're declarations. These are all just declarations, right? They're constants and they're variables that they're creating. Our language doesn't require you to do declarations. It does for constants or whatever. But anyways, we have multiple lines here because these are just setting values. They're not calculations. When you're starting to do calculations, each one of those goes in its own rectangle. And that's an annotation. I haven't been doing annotation. I'm not going to ask y'all to do it either. That's what it is. Examples of comments. Comments are like the annotations shown in the flowchart. Square feet is the estimate. Price per foot is determined by current market conditions. Lot premium depends on amenities, such as whether the lot is waterfront. Choosing identifiers. Use meaningful names for your identifier, which makes it self-documenting. What does that mean? In my code there, with the variables, SQ feet, that's a lot better than if I just called it S, right? If you look at SQ feet, you know what that variable means. S, you don't. Price per foot, if you overly abbreviated it, PPF, well, you know what it means. But it'd be a lot better to call it price per foot. It's more typing, but you can always copy and paste a variable name, right? I'm going to be using this variable name again. I could copy it. I could paste it later. One thing you can do is create a variable name and then do a search and replace and change them all. But if it was just called A, that would, wreak havoc in it. You wouldn't want to do that. It's called self-documenting because the program becomes a lot easier to read if the variables have good names. Use pronounceable names. Okay. If we had, oh, fine, where'd it go? If this is called Sacco, right? I guess that's pronounceable. Go one, Q, whatever, right? That's not real good. Not real good. Under some, in advanced programming, when you're dealing with advanced concepts, you may not be able to give long variable names to everything, but try for it. These are all guidelines. Avoid confusing line breaks. Now, our programming language doesn't really beg for line breaks to begin with. You've seen me use them occasionally. But if I had some long equation, A is equal to 3 plus 4 divided by B plus, don't type this, guys. This is not going to work, right? And then this was so long that it stretched past the end of the screen, I might be tempted to go to the next line, and then add something else, divided by E to the power, what, right? These are line breaks, etc., etc., etc. Our language only supports line breaks like that under certain circumstances. If you want to use line breaks anywhere, you can use a backslash. Putting backslashes in it tells Python, oh, we have more coming up in the next line, and more coming up on the next line. Now, you almost never see me use these. That's because my code usually isn't going past the end of the line. If you had to go to the next line, though, and continue your statement, then you could do that. Let's give an example. Right? Price equals 100, right? Total equals backslash. Price plus backslash. Tax, right? I would have to assign a tax as well, right? There we go. That works. You wouldn't do that unless these were long calculations, right? Unless you wanted to comment each thing. Price determined by whatever, right? Tax rate calculated in whatever module. That would work. That is the backslash. Opposite of divide, it's the one above the enter key. I don't do it hardly ever in this language. Some languages make it easy. Some languages you don't have to use that special symbol, in which case I use line breaks all the time. Where'd my code go? There it goes. I think I'm going to delete that example. Just tuck it away in your head that you can use line breaks to break up multiple lines to make them more readable. If it makes it harder to read, don't. It's a judgment call. Using temporary variables to clarify long statements. I talked about that. We calculated the bonus separately from, the pay. We didn't need those two variables. We could have just calculated the total based on a long formula, but we broke it up. It makes it easier to double check it, right? I could print out those values, even if I'm just printing them out as a programmer. Even if I comment that print statement later, I could double check them, make sure it's working right. Do not combine multiple statements on one line. You can really do that if you want. I could have written this all in one line. I'm going to copy and paste it, and then I'm probably going to delete it. But, I could have done this. I would just have to separate everything with a semicolon. You can do that. It's not encouraged. Considered very poor form. Code is supposedly easier to read if it's like that. In this case, these statements are so short that you could kind of read it like that. But if you break it out like that, you can add comments to each line, right? What does C do? What does D do? What does E do? Here, you couldn't add those comments, right? They're all squished together. I don't do that. I guess I will leave that there. You can do this, but don't. All right. Just to show you, you can use semicolons. Some languages require semicolons at the end of each line. Python supports that. I could do that, but they're not required in this language, so we leave them off. They are required if you're going to do that. I better make sure I haven't introduced any syntax errors. All right, it's working for whatever purposes. I've already told you that these modules are not, are not doing anything in particular. They're just defined so that we can demonstrate. About time to start thinking about what our homework assignment is going to be. I really thought we would be able to get through this. We know what temporary variables are. We know what temporary variables are. We know what clear prompts are. Input your pay rate. Even better, input your pay rate in the form of, number sign, dot number sign, number sign. We did that with the interest rate. We specified that the interest rate needed to be a fraction or in the form of .00. That's a clear prompt. Echoing input. We've gone over that. Flowchart showing that. Whoa, we are going to get finished. Maintaining good programming habits. You ought to be planning your code. Once you become experienced enough, you can probably just sit down and start ripping out code. If it's an easy program to write. If it's something that you've done so many times before, you don't have to plan it out. It looks like I'm just doing this stuff off the top of my head. But I already have a plan, usually. Sometimes you see me go and revise it, and I wouldn't have done that if I planned ahead. Maintain the habit of first drawing flowcharts or writing pseudocode. Everybody hates doing that. If you work on complicated programs, it's a good idea. Even if it's not a full-fledged, right? You might at least, have a big block that says it's going to do something, getter input from user. And it's going to have another block which details, calculate interest based on input. And it's going to have another block that says output, and you might put, what it's supposed to put in the output. Not a true flow chart, but just break it up, right? Figure out, because if you're just sitting there trying to write this code and you don't have a mental image of what it's going to do, or you don't have a model to base it on, it's going to be a lot harder to write. Desk check your program logic on paper. Honestly, I'm going to skip that this time. Think carefully about the variable and module names you use. right? Pick good names. Design your program statements to be easy to read and to use. You're trying to write clearly. If you're writing an essay and your single sentence has, 20 run-on sentences, and semicolons and stuff like that, it's hard to read, and your instructor's probably going to count off on your essay. Instead, the language should be clear, easy to follow, to be persuasive. Same thing in programming. You write once and then you read it a million times. That's not true, right? In this class, you write it once, you get it to run, and then you're done. But in a professional programming environment where that code's going to last for years, there are, government agencies relying on code that was written 40 years ago. It better be easy to read, or the people who come back later and fix it are going to do a terrible job of it. And then the summary. Programs contain literals, variables, and named constants. We've talked about all those. Literals are just the numbers typed into the code, 3.14159. Variables, pay rate. Named constants, pi equals, in all caps. Arithmetic follows rules of precedence, multiplication and division before addition and subtraction. Modulus and floor division are ranked up there with multiplication. Use parentheses to change the order of precedence if you have to. Break down programming problems into modules. Now, Donna Wilson and I agree that focusing on modules in Chapter 2 was a mistake in this book. They should be shown later. I apologize for the fact that we're throwing in modules before we even understand the language fully. But we're following the book. Hierarchy charts, showing you what they do. They're just like organizational charts, showing what calls what. And then as programming becomes more complicated, the need for good planning and design increases. You can be sure that game programmers design their logic very clearly before they sit down and write a line of code, because those are extraordinarily complex programs to write. Woohoo, we're done with the chapter. We need to set a due date for the reminder. I already had a due date. It's long past. That's okay. You never have to match the due dates. These are just reminders. If you can read ahead, that's cool. If you want to wait until we finish the chapter, that's cool. I'm not going to lash out at you because you didn't meet that due date. If you did poorly on it because you took it before we were finished with the chapter, just take it again. And by the way, if you check your grades page and it doesn't match what you saw in the Mind tab, tell me. All right, do I have homework queued up for y'all? Where we are supposed to be at getting out of class at this point already. Come on. Don't hang on me. Well, we've had 5 homework assignments. I'm not sure we need a 6th, but let's see what I give the students in the other class. I don't feel like giving y'all anything that they haven't had. All right, we are done with Chapter 2. Get the Mind Tap test done. We can hang out a few minutes if y'all need help on homework. Catch up on your homework as fast as possible, please. Because I'm catching up on the grading, right? And class is done. Let's make a Dropbox. See, if I was really cool, I'd give you a homework assignment after every single lecture. I don't hear any enthusiasm from y'all about that concept. As we hit these concepts again, right, more carefully, there'll be more homework over the concepts.